For this lesson, we'll be going over frequency and phase response. On the frequency response, we'll be going over the zeros and poles as well as the orders. And on phase response, we'll be going over also zeros and poles, orders, and also the Bode gain. Now the first thing we'll be going over is frequency response. Now we did touch base on this on a previous video, which was the Bode plot video. However, for this lesson, we'll be getting a little more detail and a little more practice of how to understand your frequency response. The equations we're going to be utilizing is the same as the previous video. The Bode gain, which is 20 log of K. The also frequency response equation, which is the light blue and dark red you see there. That is how you understand your zeros and poles. For example, every numerator is considered a zero, which is plus 20 decibels per decade slope you add. And every pole, which is your denominator, is a negative 20 decibel per decade slope. The dark blue you see, the equations that have 20 log and then a square root of 1 plus and so on, that is considered your exact frequency equations. Now, very rarely will you have to use these equations. However, I'm letting you be aware they do exist and they are there. You can utilize these equations to map out a perfect slope and perfect curves of your Bode plot. However, most of the equations that we're going to be utilizing and understanding, we're just going to use straight break/corner frequency, which is your green you see down there. So you're going to see a lot of straight edges on your Bode plot. However, if you want your perfect curves and your perfect gains, you're going to have to use your exact frequency equations. Now, a very important parameter to understand when plotting out your zeros and poles is understanding the orders. Now I have 6 equations here, 3 with zeros and 3 with poles. Now the 3 with zeros are all in blue, and they all have increase in order by 1. For example, I have a first order, second order, and third order equation. Now every time I increased an order, I had to increase my slope by 20 decibels per decade. And the same is true for the poles. For every pole order I add, for example, S to the 2, S to the 3, I actually subtract my slope by negative 20 decibels per decade. So be aware you need to adjust your slopes accordingly based on your order. Now I did save the best for last, phase response. This is the trickier of the two as far as how to plot it on a Bode plot. Phase response acts a little different compared to frequency response. Frequency response, you do have zeros and poles, same as phase response. However, whether a zero is negative or positive, a zero is plus 20 decibels per decade, and if every pole is minus 20 decibels per decade. However, in phase response, your polarity matters as far as how you adjust your angles. Also, when you plot your phase response, you plot it on the corner angle, but you go a decade before and a decade after with your slope. And I'll go over this in the example problem. I also did provide the exact angle equations that you see to your right in dark blue. So if you want your perfect curves of where your phase angle is, you can utilize these equations, add them all together, and that will give you that particular dot or that particular angle for that location or that frequency. But for most majority of our problems, we'll be using the break or quarter angle, which is in green. Now, just like frequency response, phase response also you have to pay attention to the orders. So if you have a second or third order zero or a second and third order pole, you need to adjust your frequency response accordingly. For example, I have an S to the first order. All I'm going to do is add 90 degrees to my Bode plot for the angle response. Same thing with second order, add 180 degrees, third order, 270 degrees, and so on. And for poles, same thing, just go the opposite direction, negative 90, negative 180, so on and so on. Now here's where the trick comes in. You have to pay attention to your Bode gain, your K. If it's greater than 0, you don't have to worry about doing anything special. You don't have to add any degrees or any angle to anything. However, if it's less than 0, that's when you're actually going to have to adjust your angle minus 180 degrees. So you can have a 0 that has a plus 90 degrees, but if you have a negative Bode gain, that's when you have to adjust 180 degrees to the negative direction. And again, we'll go over this in a practice problem. All right, so let's start off with a relatively easy example here. We have a transfer function with 10s over s divided by 10,000 plus 1. A pretty typical transfer function when plotting your Bode plots. So the first thing we're going to find is our Bode gain. So it's 20 log of K. Now your K would be this guy right here, would be 10. So, and I'll draw it out again, that's 20 log of 10. Well, log of 10 is 1, and then times 20. That's a pretty simple one. So we're going to have a Bode gain of 20 decibels, which means if you're putting this in your Bode plot, we can start off with our first good starting point. So this is 1, and we have a gain of 20. So we know that intersects this one point right here. Okay, on to the next step. I see one pole and one zero. Well, the zero, anytime you have a zero or a pole, is understanding the order. So this is an order of 1. So right there, we have our starting slope because we have a 0 right there. So we have a starting slope of S equals 20 decibels per decade. Now that's going to be our starting slope. So this is an increasing slope. If you go back 1 decade, you should be minus 20 decibels. So see what we did here? We have an increasing slope right now. It's going from 0 decibels to 20 decibels per decade, then another 20 decibels per decade, and so on and so on. So right there, I was able to plot just with our starting slope right there. Now this slope's going to continue until we have 10,000 because our pole is 10,000. So I'm going to do another 20, so that's 40 with another decade, and then 60 at another decade, because all I'm doing is just doing 20 decibels per decade. That's all I'm doing. Pretty simple. And that's 1K, and this is going to continuously go up. So it's 80 until we get to the very top. This right here is 10K, so which means right at the very top up here is where the buck stops. So right now, all we did was we kept the same slope until we hit our pole. So 20 decibels, 20 decibels, 20 decibels, and so on and so on. So now we have a slope change. Now right at 10K, I'll keep it right there, we do minus 20 decibels per decade. Now that doesn't mean you go the opposite direction. It means you got to adjust your slope. We were going up 20. Now we got to go down 20. Well, since we're already going up 20, we got to go down 20. So if you add those together, you're going to have no slope. It's going to basically be 0 decibels per decade, which means this is going to be a straight line from here on out. So let me go ahead and get a line here. We're going to go from here to here. Then, since we had a pole, we do negative 20 decibels per decade, and it's going to look something like that. So right there, we have now found our frequency response by a very simple equation. This is nothing fancy. It's very simple. All right, now let's do our phase response. This is where it gets fun. Let me make some room here. Now, our phase response, we talked about the orders as well. When your K is positive, which this one is, you do nothing. You start at 0 degrees, or you add 0 degrees. So this one's already taken care of. Done. Now we got to look at our 0. We already have a 0 here, and it's a positive 0. We have a starting angle of 90 degrees, and it's a first order. So that's S to the 1, which means we start at 90 degrees because of that 1S on the 0. We know our starting point is right there. 90 degree starting angle until I hit 10,000, and that because my 10,000 is my pole. Now here's where the tricky part comes in. Now we know right here is 10,000. However, like I talked about earlier, angle, you do a decade before and a decade after as far as your phase response, 5 degrees at a time. Let me show you. At 10,000 right here. Well, right now I'm going to drop 45 degrees from 90. So 45 degrees from 90 is 45. That's pretty easy. So 45 is right there. I went 45 degrees drop. So we have 10K, which is a negative 45 degrees since it's a pole. Okay? So I went 45 degrees down. Anytime you have a pole or 0, you have to adjust your phase angle 1 decade before, 1 decade after. So I already went on that exact 10K mark, and I adjusted 45 degrees. Now I got to go back and add a point there. So right now, I'm at 1 decade before, and I should be at 90 degrees right there. Now I'm going to go a decade after and do another 45 degrees in the same slope direction. Right there. So I went to that point. I went negative 45 degrees, then a negative 45 degrees, after and 45 degrees before. So we're going to have a plot that looks something like this. It's going to go 90 all the way to 1K because we did 1 decade before. And then I'm going to go 45 degrees. And then another 45 degrees because we always go a decade after. So you got to adjust for decades before and after wherever your frequency is. And then you level off. So I should have an ending phase angle of 0 degrees. So this wasn't too complicated at all. However, you have to understand how the poles and zeros react as far as how these phase angles. Starting first order 0, and it started off me at 90 degrees, and then it stayed a straight line until I hit 10K. Well, just like we talked about, you got to go 1 decade before, 1 decade after when adjusting for your phase angle. So I went 1 decade before, started sloping down 45 degrees, and then 1 decade after, 45 degrees, and then I evened off my slope. So that's how you would do your phase angle for this particular equation. Let's do another one, that way we can get a little more practice. We have a similar problem, just a few more variables involved. Now we're going to do the same thing as last time. We're going to find our Bode gain first. So that's 20 log of K. So this one's going to be 20 times log of 3.16. That's that guy right there. Plug and chug that into a calculator. You bring that down, that's going to be 0.5 times 20. And then 20 times 0.5 gives us a Bode gain of 10 decibels. Okay, so that's pretty simple. So we can already plot that first dot right there. So starting 1, and we have 10. So that's 20. So this one should be 10. So right there, we know our plot's going to intersect that one point. So let me make that a little bigger. There we go. Very simple. It's always the first thing I do. I try to find my Bode gain. All right, let me clean this up, make some room. Well, the good news is we have a second order 0 right there. So for zeros, we have S2. If you have a second order, you have 40 decibels per decade. That is your starting slope for this particular plot. So that means from here all the way down, 1 decade, you're going to go down by 40. Well, since we're at 10, we're going down to negative 30. So right there, negative 30. So we're going to have a slope that increases. Next, we're going to identify our poles as well. I kind of got ahead of myself by putting that one dot, but it's not too difficult. We have one at 10 and a pole at 10K. Apparently I like that 10K. So 10 and 10K. We're going to start seeing changes in our slopes at these particular frequencies. So we have a pole at 10, which means we're going to see a change right there. And then a pole at 10K, which means we're going to see a change right there. I'm going to keep increasing by 40 decibels per decade until I hit that one spot. So 10 plus 40 is 50. So 50, 1 decade. So 10 plus 40 is 50. So I should be at 50 on the next decade, and I am. Now we're going to have a slope change. So I'm already going plus 40 decibels per decade. Now I have a pole. Well, since I have a pole, I go minus 20 decibels per decade. Now again, like we talked about, it doesn't mean you switch directions. It means you subtract 20 decibels per decade on your slope. Well, we're still increasing 20 decibels per decade. So we're still going upward, going up as fast. So now, next decade, we're going to go up by 20. So I'm on 50. So I should be on 70. So I should go, that's 60, 70. And then the next decade is 90, which is right there. And then on this next one, it's going to be about 110. Now, unfortunately, I ran out of room, so I'm just going to put it at 100 for now. So that's actually 110 decibels. I'm going to cheat just because I don't have enough room. Another pole at 10K, which is right there, which means now we subtract another 20 decibels per decade. And when you do that, we flatline. 0 decibels per decade. My handwriting looks great today. So now we're going to flatline. The good thing about frequency response, all you're doing is keeping track of your slope. So every time you go up a decade, go up 20 decibels or minus 20 decibels based on how many zeros and poles you have. So since I had a second order zero, I was able to start at 40 decibels per decade increased slope. And then every pole I had, it took the slope down a notch. So let's go ahead and plot this out and see if we can make it look clean. So I went from 30 all the way to, we're going to go to 10. And then from 10, the slope kind of levels out a little bit more, all the way up to, and then it's going to flatline right at 110. Now again, I do apologize that my Bode plot ran out of space towards the top there. Unfortunately, it's kind of hard to fit all this on one particular sheet and try to make it clear, because as soon as I put a big Bode plot in here, all this faded away. Very hard to see. Ending gain is 110 decibels because it flatlines up here. So this right here is 110. We have a nice little simple slope right there. We can do our phase response. Let me clean this up to the right. So same thing as last time. Let's pay attention to K. K is positive. Since K is positive, I already have to add 0 degrees. So that's good. Just because K is positive, K is greater than 0. Next, let's look at the order. I have a second order 0. Well, my 0, since it's second order, which is S2, it's going to give me a starting angle of 180 degrees. So right there, I have a 180 degree starting angle. So I know my phase angle is going to start right there. Now let's do our poles. Poles is going to be 10K and 10. So we know we're going to see a change before and after 10 and before and after 10K. So if I was going to actually mark this down here, let's see. That's 100, that's 10. So I'm going to see a change here. That's where my 45 degrees will be. Another change here before and after. And then going to 10K, which is right there, I want to see a change before, right on 10K, and then after. So I want to see a change on every single one of these. Poles are positive. It's going to be negative 45 degrees at 10, negative 45 degrees at 10K. In a sense, every time you have one of these poles, you're subtracting a 90 degrees before and after your decades, in a sense. However, I start off at negative 45 degrees. That way we have a starting plotting point. So let's look at 10. 10 is negative 45 degrees. So I'm at 180, and I want to subtract negative 45. I want to drop 45 degrees. That's going to give me 135 degrees, which means at 10, I'll be at 135 degrees. So if that's 20, should be right 135 degrees. So we know we dropped 45 degrees right at 10. So if you go one decade before, remember this is your slope. If you go one decade before, we're going to go up 45 degrees, which is your 180, right there. Then we're going to go one decade after, another 45 degrees. So that if you take 45 away from 135, minus 45 again, should give you 90 degrees. So we're going to go from one decade over, minus 45, and that should give me, right there, it should be 90. I have 180, going down to 135, going down to 90. All I did was take away 45 degrees at a time for these decades. Since I did one decade before, one decade after, it's going to flatline next decade. Now it looks like at 10K, we have to go down another 45 degrees. So 90 minus 45 degrees, that's easy, 45 degrees. So I'm going to drop 90 from 45, which is, since that's 90, it should be, it's right there, I have 45 degrees. And then I have to go one decade after for another 45 degrees. So 45 minus 45 equals 0. So if I go one decade after, I should have 0. For frequency response, it's very simple. Adjust your slope as soon as you hit that pole or 0. For phase response, it's a little different. You have to adjust before and after. So in a sense, you're starting one decade before, sloping downward 90 degrees, but you're sloping in such a way that you're moving 90 degrees over 2 decades. Plot this out. Should look something like this. We're going to start at 180, go all the way over, stop right there. Then we should slope down from there, 90 degrees. So I should have 90 right here. It's going to plateau for a minute just because there's no change. And then we're going to start with this decade, go down 45 degrees, then another 45, so it should be 90 to 0. And let's see if I make that clean. There we go. And then from 0 it should flatline all the way across because there's no more poles, no more zeros. Negative 45 degrees, decade before, decade after. So we moved 45 degrees, decade before, decade after. Flatlined, did the next one, negative 45 degrees, decade before, decade after. Response is the difficult of the two to understand. Frequency response is very quick and easy. You do a change as soon as you see a pole or a zero. Phase response, you got to do a decade before and a decade after. So be aware when you're plotting this out, that's the method of the madness. Let's do one more. All right, last problem. This one's actually not too difficult. It's actually smaller than the two. We have a transfer function here, but however, it's a negative transfer function. So this one is going to be a little bit more interesting compared to the other two. So same method as last time. I'm going to find our Bode gain. So 20 log of k. So I'm going to do 20 log and of 20. It's pretty simple. Plug and chug that in the calculator is going to give us 1.3. And that's times 20. And that's going to give us a final answer of 26 decibels. So our Bode gain is 26 decibels. Pretty simple. So I'm going to do what I normally do. Go right here at 1. And I'm going to put it at 26. Well, since that's 30 right there, I'm going to say right there. It's 26. Well, right now, notice how we don't have any poles. This is actually all zeros right here. There's no denominator. This is all numerators right here. So it'd be equivalent of this over 1. Pretty simple. That means we don't have a starting slope, which means this is going to be horizontal until we get to 1K. Well, 1K is right here. Let's see if I can get that 26 right there. Which means our 0 is it's going to be at 1K. So it means we're going to increase 20 decibels per decade at that point. So 26 plus 20 is going to be 46. So there's 40. And I'm going to try to do in between again. Let's do 46 right there. And then 46. Tell you what, I'll say 46, 26. I don't know if you can see that. Plus another one is 66. So there's 66. And let's see if I can go in between again. There we go. 66. And then one more decade. That's going to be 86. All I'm doing is adding 20 every time. That's all. So 86. So let's see. There's 80. And we'll say 86 is right there. It's a little slope. And right here is still 26. So same thing as last time. I did not make a change to 1K, which is that guy right there. So let's plot this out. See if we make it look pretty. Straight line until I hit 1K. I'm sloping up 20 decibels per decade. And it should look pretty even. All I did was slope up 20 decibels per decade. Again, this is a very easy one. Now you're probably thinking, what about this negative sign? Well, as we talked about earlier, and we talked about in the slides, a negative K does not affect us right now. It will affect us when we do the phase response. So let's jump right into that. So let me clean this up. Well, here's where it gets fun. Remember what I talked about earlier, where K is greater than 0, then it equals 0 degrees? Well, that's not the case. This time K is less than 0, which means we do a negative 180 degrees. So right now, starting right off the bat, we're going to start right off at negative 180 degrees. 180. And it's all because we have a negative 20 right there. That's all that means. Once you put that negative sign in there, it changes that right there. So be aware, you have this particular equation, it's going to give you a negative 180 degrees starting off. Okay. Now again, this is a 0, which means we're going to actually have an increasing slope before and after 1K. So which means we have a 0, 1K, so which means we're going to increase plus 45 degrees 1 decade before and 1 decade after. So let's go ahead and plot that. So we know where 1K is. 1K is right there. Well, if we have 180 degrees plus 45 degrees, negative 135 degrees. So we know at 1K, we should be putting a dot at negative 135. So I have 50, should be right here. So right there, it's 135 degrees. Because all I did was go 180, and then I went up to 45 degrees. That's all I did. To go 45 degrees 1 decade before, which means that's back to negative 180. And again, this is a decreasing slope, so it means it's plus 45. So if I have negative 135 plus 45 again, should give me negative 90 degrees. So going 1 decade over should be negative 90 degrees, which is that guy right there. It's 90 degrees. So I kept the same slope. I'm going up 90 degrees, but I'm going starting from 1 decade before all the way to 1 decade after. And I want to keep repeating that. That way you remember for a phase response. Since that's all we have, it's going to plateau right at that point. So after that, it should be 90 degrees for the rest of the remaining plot. So let's plot this out using our lines here. Start off at negative 180. Going to go right there. Then it's going to go up 90 degrees over 2 decades. And it's going to plateau since we have no more poles, no more zeros. There we go. There we go. That way you understand what I did there. So we started at negative 180. We have 1 0, which is that guy right there. Went up 45 degrees 1 decade before, then went up another 45 degrees 1 decade after. So in a sense, overall, I moved 90 degrees because I did it over 2 decades. So this was a really easy problem. However, I wanted to go over at least one negative problem. That way you get your feet wet on that one. All right. Hopefully I showed you enough here to try to understand frequency response and phase response. If you have any questions, please let me know, and I hope you have a good day.